All right, so we're doing domain and range. We're going to be going through and explaining the difference between domain and range and covering a little bit of functions. Let's start off with our learning goals. I can determine whether or not a set of ordered pairs represent a function, identify the domain and range based on a table, and determine whether a graph represents a function. So we're going to start off with what is a relation, because we're going to be talking about the relationship between two values. So it's a set of pairs of input and output values. So basically it's a relationship between two sets of numbers. So like if we had a table that had students represented by a number, so like an ID number, and their weight, or like if you threw a ball in the air and we measured the time in seconds and the height in feet at that time. Alright, so we can represent that algebraically three ways. So we could have a set of ordered pairs. So these brackets at the beginning and end mean that it's a set, and then of course you know what your ordered pairs are. A table and a graph. So points represented on the graph. So your input are also your x values and is also called domain. So if we look at this, that would be all of these if we had a set of ordered pairs. On our table it would be everything in the x column. And then on a graph, that would be all your x values. So if you look, this point is at 5 on x. This one's at 1 for x. 2, 3. So you get the idea. They're all the x values. And it's important to know that when you talk about input, x values, or domain, you're talking about the same thing, especially domain. So you're going to want to make a note to yourself here. Domain, x values. All right. Outputs are your y values or your range. So again, range, it's important to know that that means we're talking about y values here. Alright, so if we have a set of ordered pairs, that would be the second point in each ordered pair, the y value. And in your table, it would be your right-hand column. And then it would be, on your graph, your vertical axis. So notice again, this is at 4 on the vertical axis, this point's at 3, this one's at 1, and this one's at -5. Alright, so a function is when each element of the domain, or remember, domain x value, is paired with only one element in the range. So y value. So that means for every x, there can only be one y. So for example, all of these, we have 1 for our x value, which is 11 in our y value, 15 and 0, 2 and 4, 9 and 3. So this here, that is a function. If we look here, this is just a relation. It is not a function. Alright, function, not a function. Because if you look, we have 1, and 1 has 3 and 0 as part of its y value. So we have the same number but two different y values, so that means that it is not a function. So we call that a relation. And it's important to note that that only applies to the x values. We could have 1, 15, 2, and 9 and all have their y values be 0 or their range, and that's okay. So that is a function. But it's only when there's more than one y value for a single x value. Alright, so a lot of the easiest way to explain this is one boyfriend to one girlfriend. Some people find it helpful to think of the domain and range as people in a romantic relationship. So each number in the domain is a person, and each number in the range is a different person. So when all the people in the domain have only one boyfriend or girlfriend in the range. So again, boyfriends, x values, girlfriends, y values. That's one way to think about it. So let's look at the first example. Determine if each is a function or not a function. So we want to look at, are there repeats of x values? So we've got 4, 6, 2, and 10. None of these x values repeat, and for it to be a function, that has to be the case. It doesn't matter what the y values is. So this is a function. Here we've got 1, 2, and we've got 2 again. Not good. Bad. So, not a function. Alright? And here we have 1, 4, 9, 2, all different numbers, so that is a function. So understand that if there is a repeat of the x value only, because notice here we've got repeats of the y values, but that's okay. It's when the x value repeats that it's bad. So for this, b is not a function. Alright, so for rules for identifying the domain and range, only list each value once. Put all the values in increasing order, so from smallest to largest. Alright, so here we have a table with x and y, and we want to list a domain. Remember, domain is your x values. So here we have our x values. We have 1, 2, 3, 5, and 6. So all we have to do is write them down. Now, if they were out of order, say this went like 3, 1, 2, 6, 5, we'd have to put them in order for this. So just be aware of that. And then our range, of course, is our y. So domain is here. This is our range. And that would be 2, 5, 7, 8, and 12. And notice those are already in order, so all we have to do is write them exactly how we see them. But again, make sure they're in order from smallest to largest, and make sure that you have these brackets around the numbers when you write them down. Alright, so now for a graph, the easiest way to tell if it's a function or not is to use the vertical line test. So if a vertical line passes through more than once, like in this case, we have a vertical line, we draw through the graph and it passes through here, here, and here, that means it's not a function. But if we draw it here, it doesn't matter where we draw the line. I could draw it here, or here, or here. It doesn't matter, it only goes through the line once at any given point, so at one point, that is a function. So we need to determine whether this graph is a function or not. So if I did the vertical line test, doesn't matter where, I could put that anywhere. It only hits a function once, so yes, that is a function. We take another look at an example. We need to again determine whether it's whether the graph is a function or not. If we do a vertical line test, we can see that it hits here and here on a single vertical line. So that is not a function. Now yes, I understand that you could draw a line through this point and it only hits once. And at that point, that's great, but it has to do it for the whole graph. So it's not just in one spot, it's anywhere. So if you have any other questions, any other concerns, just please feel free to ask me in class when you see me next.